Now we are going to discuss the most important topic related to function, that is call by value and call by reference. Why I'm saying it is the most important concept? Because people are having misconception. Whenever we pass a integer or primitive data type, it is called by value, and whenever we pass some reference or data type, it is called by reference, right? But this is wrong. This concept is wrong. This is a misconception that most of the time people are giving the explanation like this. If you are passing the data, if you are passing the integer, character, float, I mean the built-in data type, primitive data type, then it is called by value. And if you are passing some reference data type, right? Reference data type means string, object, employee class, student class, product class, then it is going to be called by reference. This concept is wrong, right? People generally say when we pass primitive data type, they are passed by value. When we pass reference data type, they are passed by reference. The answer is wrong, right? So I think after today's class, you will have a clear picture on your mind that what is call by value and what is call by reference. And I will show you the call by value example using a primitive data type and using reference data type. I will show you the same example using call by reference and call by, I mean the primitive data type using call by value and primitive data type using call by reference. That means I'm going to give you 4 examples. First example, primitive data type with call by value mechanism, reference data type with call by value mechanism. Second, I will give you example, primitive data type with call by reference, reference data type with call by reference, so that you will get a clear picture. What is the main difference? What is the misconception people are having on their mind, right? So now, the first important point is in .NET framework, by default, all the objects are called by value, not called by reference. All the objects I'm saying. When I'm saying all the objects in .NET framework, whenever you create a type, whether it is a primitive data type, integer, character, or any reference data type like string, like you can say employee, student, everything, all are by default object, because object is the superclass of all the data type. If you take the example, say integer x, right? So I'm declaring x, but when I'm pressing a dot, so you can see we are getting some method equals get hash code, get type, to string, right? From where this method are coming? Can anybody tell me where this get equals, get hash code, get type, get to string, all these 4 methods are coming from where? These
Object
methods are
class.
coming. Sorry?
Object class.
Yeah. So these methods are defined in the object class. But even these methods are defined in the object class, I am able to access this using my integer data type. Why? Because now the reason is by default, whether it is a primitive data type, whether it is a user defined data type or reference data type, the parent class is directly or indirectly going to be object, right? So that's the point that you need to remember. See, so that means .NET Framework by default all the object. When I'm saying all the object, don't consider it as the reference data type. Consider it as all data type. Whether it is a primitive, whether it is a built-in, whether it is a derived, whatever may be the type is going to be object are called by value, not called by reference. That means what? Now, if you are using primitive data type like integer, character, double, or if you are using reference data type class, interface, delegate, string, they are by default going to be called by value. Don't consider that if I'm using integer, it is called by value. If I'm using string or class, interface, delegates, it is going to be called by reference. Don't consider that. If you are using primitive data type, whether you are using any reference data type, by default, they are going to call by value. How? We'll see with some example. Now, please observe this code. So can anybody tell me when I execute this program, what will happen? So first of all, I'm creating a variable of A with value 15. I'm assigning that value to B, right? And I'm modifying the value of B. And I'm printing the value of A and B here. So can anybody tell me what it will print in A and what it will print in B? What it will print in A and what it will print in B? Anybody have?
30.
Sorry, A is
15,
15 and B is
30.
30. That means what? In this case, I'm assigning this A to B and I'm modifying this B, right? Even I'm assigning A to B, and if I'm modifying B, it is not affecting the A. Why? Because this is called by value. In this case, once you run the application, you will get 15 and 20. See, 15 and 30. So the A value is 15 and B is 30. So once you modify B, it is not reflecting the same in the A variable. Why? That we need to understand, right? So what will be the printed on the console? Your answer is absolutely right, 15, right? Because it is a value data type, and by default it is passed by value, which means for the above code, the variable A has stored the value 15 in it. When we create the variable B and assign it, the value of A is copied to B, and after that you change it. If we change B, it will not reflect A. That we have seen in practical. Now, to understand this thing in better, we need to understand the memory architecture. If you want to understand the call by value and call by reference, right? So you need to understand how the data is going to be represented in memory, and whenever I'm modifying something, then how that modification takes place inside the computer memory. First of all, when you create integer A, it means one memory location will be created inside the stack area, right? And there it will store the value B. And whenever you create integer B equals to A, another memory location will be created inside the stack memory with the name B, and it will store the value. What are the value? 15, 15. Then when you modify the B value, it will modify the value B in this memory location, right? That means this is independent, this is independent. And in this case, right, so this is what we have seen. But the memory representation is like this. Inside the stack memory, we are creating this inside the main method. So this is going to be your the stack memory and the main method activation record area. So first of all, A is created. So whenever the A is created, so as I told you, every memory location having some address. So the address is 1010. You can say this is reference, or you can say this is address. So the memory location for the A variable is what? 1010. And what value it is storing? 15. And whenever you say integer B equals to A, so in the B variable, what it is storing? The value what is the A that is going to be stored, or the memory address or reference of A is going to be stored. If the value is going to be stored, then it is called by value. If the address is going to be stored, then it is called by reference. So in this case, the value is going to be stored inside the B. So see, inside the B, B is having its own address 2020. But what B is storing? It is storing 15. 15 from where it is getting the data 15? 15 is in nothing but the A value. So in A, the value is 15. And B, in this case, we are assigning the value to the variable B. We are not assigning the reference or address of A to B. We are assigning the value. Whenever you are assigning the value to another variable, this is said to be called by value. In this case, 15 is assigned to this variable. Yes or no? Hello? Hello?
Yes, sir, got it. Yeah.
Yeah, got it. So instead of 15, if I am assigning 1010 somehow, then that is said to be called by reference, right? As I am assigning the value, so it is called by value. If I am assigning reference, that is called by reference. That we will see how to assign the reference, that we will also see. So this is called by value mechanism. So whenever, if you want to understand the call by value and call by reference mechanism, first of all, you need to understand the memory architecture. If I am creating a variable, it is having two things. It is having value and it is having some memory location, memory address or reference. If I'm assigning that variable to another variable, what it is assigning? The value it is stored, assigning the value, or the memory address or reference of that variable is assigned to the variable. If value is assigned, then it is called by value. If reference is assigned, then it is called by reference. So in this case, it is assigning the value. So it is called by value mechanism. Is that clear? Yes or no?
Yes, sir.
Okay. I'm just writing the same example. So in the previous example, I assigned A. In the previous example, what I have done is I have done this thing, right? I have done this thing. So now what I'm doing now, instead of these two things, I have moved to a method. So in this case, this is a method update value, and this integer b, it is like a local parameter. And here I'm passing that a value to this, and here I'm assigning this. So this is the same thing. Whatever we discussed in our previous example, the same thing. In this case, the value of a is passed to value of b, right? So in this case, whatever the value stored inside the a variable is passed to this b variable. So it is called by value. So whenever we are calling a method by passing the value of the variable, then it is said to be called by value. It doesn't matter whether the data type is a primitive data type or a reference data type. If the variable's value you are passing, then it is said to be called by value. Is that clear?
Yes, sir.
Okay. Now let's observe. Call by reference with call by value with reference type. Here only, so people are not getting confused with this example. People are getting confused with this example, right? So tell me. Okay, so here I'm having one user defined type. So this is not a user defined class. So this is a user defined class. User defined class means it is a reference type. Reference type. See, so in this case, I'm creating one employee object. Then I'm assigning that employee object to another employee class. So this is a reference variable employee one, which is pointing to one object. This is another reference variable, but here we are assigning this employee one reference variable to this. And then I'm modifying this employee one object. So people are getting confused in this type. People are saying that this is called by reference. Wrong. This is called by value. So in this case, if I'm printing emp1.name, it will print Smith, but in emp2.name, it is not modifying the employee to object name. Now please observe. Sure. In both the cases, it is printing the name Smith, right? So to understand, so people are actually getting confused. Okay, this time, see, people are thinking that we are updating the employee one object, and once you update the employee one object, it is also affecting the employee two object. That means it is called by reference, because we are able to modify the value of one object using another object, and people are thinking that this is called by reference, but this concept is wrong. To understand this concept perfectly, we need to understand the memory architecture of this program, right? So first of all, see, okay, let's execute this program step by step. Okay, now, okay, let's give you a breakpoint here, and let's try to execute this code. So I'm just creating one object, and I'm assigning these two variables, right? I'm not executing this employee two object yet. So this first three statements are executed. When the first three statements are executed, what will happen? See, every time the object is going to be created in the heap memory, and the reference variable is going to be created in the stack memory. So this in heap memory, the object is created. What is the object? Employee object. This employee object is created with two properties. One is employee name and another is name. So employee ID and name. These are the data member of an employee. So these two are going to be created inside the heap object. Let me close these two. Okay. So here you can see employee object is created. Where it is created? It is created in the heap memory. And this employee object having two data member. Why? Because this employee class having two properties, employee ID and name. So this variable and this variable, two variable. So this employee object is created with two variable. And what is the address of this employee object? This employee object address is 101011. This is the memory address of employee object. And then this memory address is stored inside the employee one reference variable. And this employee one reference variable is going to be created in the stack memory. Give me 1 minute. See, so what is the address of the employee object? or what is the reference of the employee object? 101011. Understand or not? Hello? Hello?
Yes, sir.
Yeah. So I need your input also, because it is like, yeah, I'm always going to speak and you are idle. This will not be the case, right? So here employee object is this one. This employee object is created in the heap memory. So whenever you are creating an object, that object is going to be created in the heap memory, and this is the nothing but this memory reference address. What is the address? Address is 101011, right? This employee address is going to be stored in the emp1 reference variable. Why we are calling this this as a reference variable? Because it is not storing the value, rather it is storing the reference or the address of an employee object where the actual data is being stored. In this employee object, the actual data is stored. And this emp1 reference, why I'm saying emp1 as a reference variable? Because this employee one is not storing the value. This employee ID1 name James, this is not storing this. Rather, it is storing the reference address of an object. So what is the address? 101011. So this 101011, this emp1 is stored. And please observe, this employee one reference is this one. So employee one address is 111000. Employee one value, what is here? What value it is storing here? It is storing the value 1011. That value is nothing but the address of the employee object. Is that clear? Guys, is that clear?
Yes, sir.
Guys, please be participate in the session. Don't be sit ideally. Okay, so in this case, this 1010 is nothing but the value, and this value is nothing but it is the reference address of the employee object, and the employee one reference address is this one. So now when we execute this statement, what will happen? And when we execute this statement, what will happen? That we need to understand. See, I'm pressing F10 and I'm pressing F10. So when this statement is executed, what will happen? Then we will see this one, right? Please observe the below image. When this statement is executed, another reference variable will be created. What is emp2? Okay, no issue. So see, employee2 object is created. So employee2 reference variable is created. And what we are doing here, we are assigning employee1 value. So in this case, please observe, this employee2 reference variable is created inside the stack memory. And what we are assigning? We are assigning employee1. So please observe, employee1 value is this one. Employee1 address is this one. What we are assigning to employee2? Its value or its address? We are assigning its value 101011. So this is called by value. We are not assigning this address to this employee2. Rather, we are assigning the value that employee1 holding to employee2. This is called by value. Now, so this 1010 is assigned to this variable, employee2 reference variable. That means employee2 is now also pointing to the same object or not?
Yes.
Yes. Now, if you do any changes using emp1.name, that means this name will emp1.name equals to James or Smith. So this is wrong, guys. So instead of James, it should be Smith, right? Okay, that you need to understand. This is not James, this is Smith, right? So it will update this James value to Smith. And once it updates, and where it is updating the data, it is updating the data in the employee object. That means once you update the data here, then this updated information will available to both this reference object or not, because both are pointing to the same memory location. Is that clear?
Yes, sir. Got it. Yeah.
See, so here, whenever we are assigning this statement, we are not assigning the reference of emp1. What we are assigning? We are assigning the address, we are assigning the value. So this is the value and this is the reference address. That value is the reference of employee object, but that is not the problem. But in this assignment, we are assigning the value, not the address. Instead of this, if we are assigning this one, then it is said to be called by reference. But we are not assigning the reference address of a EMP1. We are assigning what EMP1 holding the EMP1 value. That value we are assigning to the employee to reference variable, or you can say employee to object, right? So in this case, as we are assigning the value, so it is said to be called by value mechanism. Then now you understand why we are getting the name as both in both the employee reference variable. We are getting the name as Smith, because whenever we update the name using employee one object, then that updation is happened inside the employee object, which is inside the heap memory. And once you do any modification to this object, the number of references this employee object has, all will get the updated value. Now this employee one reference, this employee one value is pointing to this object. This employee two value is also pointing to the same object. That means this updation, this modification is also applicable to employee two object. Is that clear? This is called by value. As of now, the example we have seen using the built-in data type or using the primitive data type like integer, character, or float, or using this user-defined or reference data type employee. So we are passing only the value that they are holding. We are not passing the reference of the variable. So this is called by value mechanism. Is that clear?
Yes, sir.
Okay. Now, please observe this one. It is also very important. Okay. So now you can see. What we have done here is we are created one variable, right? We are created one employee object, and we are calling this object name method by passing the employee object. The same, whatever example we have discussed in the previous example, we are doing the same thing. So what we are doing here is, okay, let me copy the code so that you will get better idea. Okay, so in our previous example, we use this one, employee one, we are assigning to employee two. In this case, we are also doing the same thing, but this statement is written inside a function, right? Inside this function, update name. So here we are passing this employee one, right, to this employee object. So this employee two. So the same thing. This is the memory architecture. What we discussed in the previous example is the same one. In this case, we are just passing the value that is held by employee one object to this employee two object, right? And now observe, if I'm making employee two as null, then if I'm accessing this employee one object equals to like this, then what output we will get? Can anybody tell me? Anyone having any idea what will be the output of this example?
Null.
Null value.
Null value.
Yes.
Why null value?
Because in the update function, we are assigning that object as a null.
Okay, so please observe, right? So to understand this, you need to understand the memory architecture. This is the example employee, right? See, whenever you are making employee two null, that means, so this whatever the value this employee two object is holding, that will become null. Yes or no?
Yes, sir.
So that means this employee two object is holding this value previously 101011.
Yes, sir.
That means this value will become null.
Yes, sir.
So once this value will become null, that means the reference, this reference will be deleted.
Yeah.
It's no more pointing to the employee object, right? But does it mean this reference is deleted? Employee one reference is deleted or not?
Not deleted.
Sorry?
Not deleted.
Okay, if not deleted, then can you access this employee object data using employee one reference variable?
Yes.
So in this case, if I'm trying to access the name variable using employee one, So should it give me null or should it gives you gems?
James. James.
James.
Gems, na?
Yes, sir.
Okay. Now observe the output. Gems you are getting? Yes or no?
Yes, sir.
Yes.
Is that clear?
Yes, sir.
Okay. Now one more thing. Because these are the things that you need to understand. So now what I'm doing here, I'm modifying the data. Now can anybody tell me what will be the output?
James only.
Gems only. Are you sure?
MP2.
Yes, sir.
Okay. Wrong. See, in this example, before making this employee to null, right? Before making this employee to object as null, so it will execute this statement or not?
Okay, sorry, sir. It will overwrite value with Smith, right?
Right? Before making this null, so whenever it execute this statement, so this value will be updated or not? So this James value will be updated to Smith, and then it will execute this statement. Once the second statement is executed, this will become null, so this reference will be deleted. But when employee one try to access the name property, it will have that updated value Smith. Is that clear? Yes or no?
Yes, sir.
Are you sure or no? Still you are confused?
Sure, sir.
Sure, no? Okay. Not this one. Right? So when this statement is executed, this thing is going to be happen. Yes or no? So employee one object is created, employee two object is created. This employee one holding this value is assigned to employee two. This employee two having the base address this one. This employee one having the address this one. Now, when this statement is executed, so it will update this James value to Smith, right? And when this statement employee two object is executed, so in this case, this value will become, so this will be deleted, and instead of this will become null, right? So this will become null. Once it become null, then what will happen? Now, so this reference will be deleted, right? So there is no more reference. Employee two cannot access to this employee object, but still this employee one having a reference to this employee object or not. So when this statement is executed, say employee one will trying to access the name variable. So in this case, what is stored in the name variable? It is storing Smith. So it will print you Smith in this example, right? You understood now? Smith. Clear or still doubt?
Yes, sir. Clear.
Clear. Okay, fine. So in this case, the two examples that we have discussed so far, or whatever example we have discussed so far, whenever we are assigning employee one to employee two, so what it is actually assigning? It is actually assigning the value it is holding or the address of this variable. What it is actually assigning? Can anybody tell me? The value or the address? So this is the value employee one holding. This is the address of the employee one.
Sir, instead assigning the value.
So whenever if it is a built-in data type or a primitive data type, doesn't matter. If it is assigning the value to a variable, or if it is passing the value to a function, right? So this is said to be call by value. So in this case, so the value what is the employee one having, that will pass to this function, and that value will be stored inside this employee two reference variable. See, so the value of employee one is 10101. 101011. So this employee one value is stored inside this employee two variable. So this is said to be called by value mechanism in C#. The same thing is also happening in the case of a built-in data type. So in built-in data type, you can see this is the memory address of variable a is 1010, value is 15. When we assign a to b, so in that case 15 is assigned to the variable b whose memory address is 2020. Then we modify b. In this case, this modification is only applicable to this variable because this is a primitive data type, right? Everything is happening inside the stack memory. But when coming to the reference data type, the object is created inside the heap memory. The reference variable is created inside the stack memory, right? So in this case, the variables or the object is created in the heap memory, the object having some address, and that address is going to store inside the reference variable. And whenever we do some kind of a assignment like this, so the value that is the employee 1 is holding, that will be assigned to the employee 2, not the reference address of employee 1. If reference address is assigned, then it is going to be called by reference. But in this case, the value what employee 1 is holding, that is assigned to employee 2. So it is called by value. So this is all about call by value mechanism, and this is the architecture we have seen now. Now we will see call by reference. See, now we are going to discuss the call by reference, or sometimes people are also saying pass by reference. So don't be confused with the term call by value or call by pass by value or call by reference or pass by reference. Both are going to be same. So now we are also going to see the example call by reference with both the primitive data type like integer, character, or you can say float, as well as using a reference data type like the one we have created, employee. For call by, okay, now one more thing, guys, you need to remember, if you want to implement call by reference, whether it is with a primitive data type like integer or character, float, or using user defined data type, you need to define the parameter with the ref keyword. You need to define the parameter with the ref keyword. Once you define the parameter with the ref keyword, then it is said to be call by reference, right? So this is the point that you need to example, right? Now, so this is the example using built-in data type. So you can see here I'm declaring an integer variable a, and this is the method to whom I need to pass the value, right? But here reference int b. So here in the previous example I have used only int b, but now I am using a ref int b. When I used to ref int b, it means now the function call is going to be called by reference only. See, so while calling the method, if you instead before passing the argument, you need to specify the ref keyword. So once you specify the ref keyword, then it is going to be called by a reference only. So called by reference. Now, so how? Now see, if I am not going to use the ref keyword, then it will give me error. Why? The reason is, okay, please observe. Argument 1 must be passed with the ref keyword. Why? Because we have defined the method in such a way that the method b is not going to be called by value. It should be called by reference. And if you are passing the a, simply a, then it is going to be value type. So if you are using a, means whatever the value stored inside the a variable, it is going to pass. But that is not our requirement. What we want, the memory address of the variable a we want to pass. If you want to pass the memory address of the variable a, then you need to use the ref keyword. And so once you use the ref keyword, then what will happen? Now this memory address, what is a value is holding, will be assigned to this memory b. Is that clear?
Hello.
Yeah.
So, like, sir, this ref keyword is used to retrieve the memory address.
Right. If you want to assign the memory address of one variable to another variable, then you need to use ref keyword. Another option is there, that is out keyword, that we will discuss later. But for now, you need to use the ref keyword.
So,
Right.
like, can we use this like inside like this right line also to see the memory address?
Yeah, I mean, you want to write like this.
Yeah.
See, it is going to give you error. You cannot do like this. But if you want, you cannot, because this is not acceptable, may not be passed with the rep keyword. You cannot.
So is there any other way to like retrieve the address?
I have not tried this one, but I think no, this is not. Yeah, I think you can use that ampersand a.
Okay.
I think ampersand a is there now. That I will show, but I have not
Yeah.
tried to print
Yeah.
the
Yeah.
reference. But I think in the pointer concept, I have shown you how to print the address. Okay, let me open the data type, because that is not. So it is an on-shape code, na? You cannot run this code directly. So what you need to do, you need to go to properties and you need to go to this section and allow on-shape code. Once you allow on-shape code, then this program is going to work, right? So see, if you want to store address, you need a pointer variable, and here I'm printing the address. So address is always going to be positive integer number. See, this is the address. You can use ampersand to print the address. But to store the address, you know what is required. We need pointer, right? So we are using a pointer to store the address, and you can print the address. And address is always going to be positive integer, so I just convert that to int. But this is on-shape code, right? You should not use this code. If you are executing, then it is your responsibility. .NET Framework is not going to manage this code because this code is not safe to execute.
So
Right? So
basically, to retrieve the address, first we need to declare a pointer, and then it's
obviously,
like,
yeah, because if you have any experience of a pointer concept, what is pointer? Pointer is a variable which is hold the address of another variable.
yeah.
Yes or no? So if you want to print the address, then you need to use the pointer. But this is pointer concept is on-shape, and that's why in .NET Framework we are going to use ref keyword. We are not going to print the address, rather we are just going to assign the address, and to
Yeah.
do that we are using a ref keyword. Is
Yes,
that
sir.
clear? So
Yes,
now this ref is going to hold the address of a variable. Right now, if you modify this value, then it will also modify this a. Right? So in this case, a is assigned with 15, right? I call this method update value, and here I'm passing the value by reference, right? As you are passing the value by reference, and what b is pointing to, what b is pointing, so b is not point, b is pointing the address of this variable. So that I will show you practically how to memory load. So can anybody tell me if a address is assigned to b, is there any chance that two memory location having the same memory address? No, there is no chance, right? So that I will show you practically how the memory architecture is implemented. But for now, if you are assigning 15 and you are calling this method by reference, so calling by reference means this is reference, you need to use the ref keyword, and here whatever updation you have done using this b, that will also affect it to this a. So whenever then when you print the value of a, it will not print 15, it will print 30. Right? Now, to understand this, you need to understand the memory architecture. So first of all, a is created. Right? First of all, variable a is created. Right? Okay. So when this statement is executed, a is created with the value 15. So this is a, and its value is going to be 15. And let's say its address is going to be 101011. So this statement is going to be executed, right? Now, when you pass ref of a to b, so it is not going to create a new memory location for the b variable, right? You are just assigning the address. Using same address, you cannot create another memory location inside the same stack memory. So what he will do, it will access, so the b variable will also access, so this b variable is also going to access the same memory location. So what it means, so whenever you are passing ref A to int B, so in this case, B is pointing to the same memory location which is pointed by the variable A. So in this case, so it is like this. So B A is pointing to this memory address, right? B is also pointing to the same memory address, because in this case we are not passing value, we are passing address. That means this B memory location, this B is also having the same memory address which is of A. So in this case, you can say that B is an alternative or another name of the variable A. Is that clear? Now using B, if you modify 30, B is also pointing to this memory location or not? So it will modify the value here also. So this value is removed and it will update this value to 30. So once it update the value, it will complete and it will come back. And when A is accessing, so what value is stored inside A? The same 30. 30 is there. So it will print the value 30. So in this case, whenever you are using ref keyword, a new memory location is not going to be created. But in our previous example, if you look at the example, whenever you are assigning A to B, a new memory location is going to be created for A as well as new memory location for B. But in this case, no new memory location. The memory location is shared by both the reference variable A and B. A is created, actually A is created with the memory location, and whenever we are passing the address of A to B, the B is pointing to the same memory location. It is not going to create a new memory location. So B is an alternative or other name or certain name you can say to access the memory location which is created by A variable. So in this case, if you are modifying the value using B variable, it will modify the value inside this memory location. Right? B equals to 30 means it will modify the value here also. So if you try to access the variable using A, or if you want to access the value using B, the same memory location is going to be accessed by both the variables A and B. A memory address is same, B memory address is same. So if you are doing any changes in this memory location, then the changes is going to be reflected in both the variable. A will, because A is accessing to this memory location, B is also accessing to this memory location. Is that clear? Guys?
Yes.
Yes, sir. Yes, sir.
Okay. Now we are going to discuss the same thing using call by reference. Same thing means what? Now I'm working with the same example, right? So same example, so I'm creating one employee object. I'm calling this employee object to this employee one method, right? And I'm passing the reference of this one. Now, so what I'm doing here, I'm just making employee to name equals to Smith. So I'm just modifying something here, right? So what will happen? In this case, we are passing the reference of employee one, and this reference is going to be held by the employee two object. And using employee two object, I'm doing some modification, and then I'm making the object value as null, employee two is as null. So in this case, can anybody tell me what will be the output? Can anybody tell me the output? This is the same example. This example we have seen using call by value mechanism, but now the only difference is that we have added this ref keyword. When we add the ref keyword, it is going to be called by reference. In this case, you are saying the output will be null. Any other output? Is there any chance we will get James, or is there any chance we will get the output as Smith, or anything else? Okay. Now, please observe the memory architecture so that you will get better idea. You will get some object reference error. Why? That we will discuss. Right? Okay. Okay. Now, so when these three statements are executed, this thing is going to be happened in the computer memory. Is there anything I need to explain regarding this image? This employee object is created with this value. The employee object address is this one, and this address is going to be stored by employee one reference variable. And the employee one reference variable is also having its own address, right? So now this is the thing is happening inside the computer memory when these three things are happening. Now, whenever we pass the employee one reference one, that means this reference address, this address is going to be passed. So this address is going to be passed for this employee two, right? So employee two, what it means? It means this employee two object also having the same address. So in this case, both employee one and employee two having the same address. So you cannot create two memory location with the same address in the stack memory. So what you can do, we can create two reference variable pointing to the same memory location, right? So in this case, when you are passing call by reference, so both employee one and employee two having the same memory address, right? So employee one having the same address, the same address is shared with the employee two also. That means now you can access this object using either employee one or by using employee two. Is that clear?
So basically, sir, we are using two variables like employee one and employee two, and both are pointing to the same memory address.
Exactly, because here we are passing the reference. Now, if you do any modification, employee two equal dot name equals to Smith, then what he will do? Say employee two, I mean this memory address pointing to whom? This object. So this object value is going to be changed. What it will happen? This James will be replaced with a Smith.
Yeah, sir.
Right. And then please observe. And then we are making employee two as null. Employee two value is null means what value it will, which value it will make null? It will make null to this value or not?
Yes, sir.
It will make null to this value. So when this value becomes null, what it means, this reference is going to be deleted or not?
Yes, sir.
So this reference is deleted means now both the employee reference is deleted or not? Because both are having the same memory location.
Yes, sir.
Yeah, deleted now. Now when both the references are deleted, that means currently EMP1 and EMP2 holding what value?
Null.
Null value. Then if null value is there, can I access the name property?
No, sir. Yeah.
So whenever your object is having some null value, you cannot access the name property because it doesn't know which object, which employee object name. It might be possible that in your application you have multiple employee objects. Then which employee object value I need to access? I cannot identify because the object value is null. Whenever the object value is null, and if you are trying to access the property of an object, then you will get null reference exception. Please be observed. So in your real-time application, you will get this type of exception many times, right? You will run the application and runtime you will get some null reference exception. So null reference exception means your reference object having the null value and you are trying to access the property of an object. So in this case, when this statement is going to be executed, it will give you some null reference exception.
Sir, just a quick question, like sir, like here we are like using employee one dot name. So like EMP1 is the object, and like using this object, we are accessing this name property.
Right, EMP1 dot name means EMP1 what value it is holding? 101011.
Yeah.
So 101011, where it is created, where this memory address is created, it is created inside the stack memory. So from this from this address, please access the name property. So is there any name property in this memory address? Yes, there is a name property in this memory. So whatever the value is there, please take that value. So in this way, it will access.
Yes, sir. Okay.
Clear?
Yes, sir.
So now, if you run this application, then you will get some exception. So this is called by reference, right? So previously we are not getting any error because that is called by value. But now we are getting some error because this is called by reference. And in call by reference, the point that you need to remember, in the case of a call by reference, new memory allocation is not there, whether it is a built-in data type or whether it is a user-defined data type. New memory allocation is not there. Rather, both the reference variable will access the same memory. Is that clear?
Yes, sir.
Okay. So if anybody having any doubt related to today's session, they can ask me the question.
So, sir, like if we want to solve this error, so like how can we solve this? Just simply like in that code only.
In the if you don't want to see, you can implement track as exception, na?
Okay, yeah.
Right? So exception handling is there, and in our upcoming article, right, I will explain you when to use ref, when to use out keyword, right? Difference between ref and out. So the concept is there, because if ref concept is provided, then there should be some use cases, na? What is the use cases that we will discuss later, but how to use that we will discuss now. There is some concept, because we are currently only studying the basic part, right? Once the basic is completed, then we will see the actual part. So now you can see in call by value, the copy of the original variable is passed to the call function. In call by value, the value of the original parameter is copied into the parameter of the function. As a result, if you do any modification of formal parameter, they do not have any impact on the actual parameter. It will not allow to change the actual variables using function call. The memory location referred by formal parameter and actual arguments are different. It doesn't require ref or out keyword. In call by reference, the reference, that is the actual address of the variable, is passed to the function, right? In call by value, the formal parameter and actual parameter both point to the same memory address. As a result, any changes made to the formal parameter are also reflected in the actual parameter. It allows you to change the actual variable's value using function call. The memory location referred by formal parameter and actual parameter are the same. It requires ref or out keyword to achieve call by reference in C#. So whatever we discussed, this is thus the summary. Right? So whenever it allows change the actual variables value. So actual variables value in the sense, don't consider this value. Variables value means this value. This is the value. This is the reference address. So using EMP1, you can modify this. Using employee2, you can also modify this. So is that clear? Any question related to because people are getting confused. What they confused? People are getting confused at if I am passing. See here if I am creating the employee object like this is called by reference. This is not called by reference, because in this case this variable memory location is exist. Even this variable memory location will also be created, right? So whatever value this employee object is holding, that will be assigned into the value of this employee too, but both are having two different memory location, right? So in this case, if this object is deleted or it become null, then it doesn't impact on this employee object, because this is called by value, no impact on the actual variable or the formal variable. But if you are using a reference object, then you need to use your ref also. And in this case, both are pointing to the same memory location. So if you modify this employee object like this, if you make it null, that means this employee one will also become null. But in previous case, it is not the case. If you are making employee 2 is null, that means it will only remove the employee 2 reference. It will not remove the employee 1 reference. You can still access the employee object using employee 1. See, in this case, we are not getting any error, right? So you will get the updated value. But now if you make this as a reference, right? So you will get error, because the both are having the same memory location. And if you modify the memory location using employee 2, then it will also affect this one. Now both will become null and you will get the runtime error. So see, object reference not set to an instance of Java. So what error we are getting? We are getting null reference exception.